Well, thank you very much, Jean-Pierre, and thank you, David, for inviting me to participate in this event, and especially thank you to Per. It's a tremendous honor to get to participate in an event in your honor. You've been a hugely influential person in my own career, and so as David invited me to prepare something for this, I had to spend a lot of time thinking hard about what could I prepare that would suitably honor Per, but also have some root in something I perhaps know something about. And David can attest it took a long time because I was very slow in responding to him. And he kindly chalked that up to I was on sabbatical. But it was really time to reflect. It took longer than it should have. So I decided to prepare something, and Leah Bevis, a PhD candidate here at Cornell, kindly agreed to join me as a co-author in this. I decided to prepare something that would merge two of Per's very influential streams of writing. So Per is, as everyone in this audience knows, one of the most insightful thinkers about the holistic experience of food, from the production through the marketing channel to the consumer's experience, and is constantly pushing all of us to think carefully about the whole system, not just think about production agriculture, not just think about consumer behavior, not just to think about agricultural marketing, but to understand the linkages and the many different entry points that policymakers face as we try to think about addressing the complex problems surrounding malnutrition, hunger, and poverty. And Per has written about this extensively and had a big influence on my own thinking about food systems. One particular area in which he's also been very influential is in calling attention to the triple burden of malnutrition, that although policymakers have this propensity to keep talking about 842 million hungry people, or whatever the number of the day might be, that is one particular, frankly very bad, measure of malnutrition. And that perhaps the more alarming measures of malnutrition commonly overlooked in the developing world around obesity, and perhaps especially around micronutrient deficiencies. So this paper takes a look, or takes a stab at merging the two of those threads of Per's own writing, and doing so in a context of African food systems. And the real motivation behind this is my own interest in poverty traps. The reason is that persistent severe micronutrient deficiency is arguably the most powerful poverty trap mechanism we know of. Two children born in otherwise identical circumstances, we know very well that severe iodine deficiency early in that child's lifetime will lead to permanent cognitive impairment, and therefore permanently reduced economic performance, shorter lifespan, shorter physical stature, more health problems, etc. Same thing for severe persistent vitamin A deficiency. Leads single largest cause of blindness among children. You name it, the micronutrient deficiencies build and create permanent cognitive problems and permanent physical problems for populations that trap them in long-term poverty. And the real challenge here is that poor populations face micronutrient deficiencies with alarming prevalence. So this is a very simple scatter plot and series of bivariate logarithmic regressions of the prevalence of different measures of malnutrition, from stunting, severe short stature relative to age, wasting, severe underweight relative to height, vitamin A deficiency, goiter rates, and anemia as reflections of, as indicators of particular micronutrient deficiencies. All mapped against the gross national income per capita measure as reported by the World Bank. And what you'll notice immediately is wasting, which is really about the closest thing to that headline measure of undernourishment that the FAO provides. Wasting starts off at a much lower rate, especially for very poor populations, than any of these other indicators, and falls, other than vitamin A, falls relatively rapidly. So this blue line is wasting. If you can see all the blue scatter plots, this is just the simple logarithmic regression of wasting prevalence or wasting rates rather, on GNI per capita. Vitamin A deficiency falls quite quickly as one comes from very low incomes to somewhat higher incomes. But all of these others, stunting and various indicators of micronutrient deficiencies, which are all indicators of very persistent problems, long-term problems, are much slower to fall and remain at very high rates. So we see that the middle income, the upper bound of the World Bank's middle income range is $12,000 and some dollars per capita. And at that range, all of these other indicators remain well above 10%. So a very high rate of incidence of these problems persists throughout the low and middle income range. This is both a problem and a puzzle. A puzzle because it's not self-evident why we see this extraordinary persistence at a relatively high rate of micronutrient deficiencies, and a puzzle because it's not obvious where one intervenes to try to address this problem. I already mentioned the reason why this becomes urgent is the poverty trap problem, the problem that permanent impairment, permanent cognitive and physical impairment result from sustained severe micronutrient deficiencies. So why do these problems result? Well, this is where Pear's standard answer, if you need to think about this holistically, you need to think about the food system in its totality, really becomes important because micronutrient deficiencies originate at every stage along the food system, along the food value chain, from the deficiencies in the soils, where the classic case being iodine deficiency. The primary source of iodine is seawater. When you're in mountainous areas quite remote from sea and people aren't consuming a lot of seafood, iodine deficiency is a really big problem unless they're consuming iodized salt. Through the marketing channel, the iodization of salt is an explicit intervention to introduce a micronutrient absent from the natural food production system for particular areas. Through the consumer choices, some people choose not to consume iodized salt and thereby wind up suffering from iodine deficiency problems, goiter, their children suffer cretinism, etc. So you need to understand the interlinkages between producer, consumer, and marketing intermediaries and the various places in the channel where you can intervene. Different communities focus on different groups. So consumer choice problems, then the problems of information, the potential of nutritional education, making moms aware of the vitamin and mineral content of key foods, helping them to choose the foods that are best for their children at those critical formative years. That's a focus of one particular community. Understanding the nutritional transition that happens more broadly as incomes grow and the opportunity cost of time increases. People begin choosing more convenience foods. They wind up eating more street food that may be lower in minerals and vitamins, higher in fats and calories. That's another candidate explanation. The rise of urbanization plays into that. How relative prices change and what that means to consumers. These are all candidate explanations on the consumer side, and surely they have some explanatory power for at least some subpopulations, but it's not always clear how general these are and how applicable they are to other subpopulations. So a very rural subpopulation that has very high rates of micronutrient deficiencies, consumer explanations might not always be the best part of the story to focus on. The food marketing chain is a big place. Many minerals and vitamins deteriorate very quickly in foods that are perishable if not preserved properly. So this gives rise to questions about preservation, about refrigeration, storage practices, et cetera, that are all about the marketing chain. Food processing, how one takes the bran off of grains when you mill a grain. Is it still there with all of the relatively rich content of the bran as is commonly present in artisanally milled rice, wheat, sorghum, et cetera, and commonly lost when we go to larger scale industrial processing at scale. Fortification as an opportunity to remedy deficiencies that exist in products in their natural form. And then there's the producer side where farmer cropping choices, green revolution technologies that have promoted, perhaps inadvertently, monoculture and have oftentimes crowded out the production of legumes and in some cases vegetables, can have implications for per capita availability of minerals and vitamins. Agricultural practices, inorganic fertilizer use, very complicated synergies between introduced nutrients in an agroecosystem and minerals and vitamins in the fruits and vegetables and animal products and grains. The micronutrient deficiencies in soils are, as I already mentioned, a big issue. And the hot topic today, really, especially with Harvest Choice and Harvest Plus in the CGIR, surround biofortification and the potential of getting the genome of particular species to begin producing micronutrients in crops where they weren't otherwise plentiful, and thereby solving at the producer level the mineral vitamin supply problem. So with that, I'd like to pass the baton over to Leah to walk you through this in a little bit more detail. That's the overview. The punchline is there are so many entry points, and we have lots of little bits of data across different parts of this food system, but we really lack any holistic understanding right now of the sort that good policy analysts like Pear prize. We lack any holistic understanding of where really are the best places to intervene. And we lack any very comprehensive set of methods for targeting for particular populations. Where would you intervene? We have instincts, but we don't even have right now very reliable, well-documented rules of thumb. So there's an enormous research agenda out there around micronutrient deficiencies within a food systems context, especially in Africa. And with that, let me hand it over to Leah.
Just like Chris said, I'll go into these in a little bit more detail. Consumers clearly make choices that affect their micronutrient intake. For instance, many consumers may not realize that they're micronutrient deficient. A lot of micronutrient deficiencies don't manifest in any clear sensory way. If this is the root cause of micronutrient deficiencies in at least some populations, it would imply that education or increased information would be a potential solution for decreasing these rates of micronutrient malnutrition for those people. On a more structural level, rising income is associated with a nutritional transition that a number of people have already referenced today, and a accompanying epidemiological transition. So this nutritional transition is characterized by a shift in the types of staples people are consuming, an increase in animal-sourced food, and an increase in fats, oils, and salts and sugars consumed. There's not a clear implication for micronutrient intake, I think, for everybody, but on a case-by-case basis, you may be able to tease out some patterns. If a population is switching from primarily tuber staples to primarily whole grain staples, they may end up consuming a lot more iron or zinc or other vitamins. If, on the other hand, they're shifting from sorghum or millet to a really processed form of grains such as polished rice, perhaps the opposite might be true. Increased consumption of animal-sourced foods can almost do nothing, I would say, besides increase at least the intake and bioavailability of zinc and iron, and perhaps some other trace minerals. Hand in hand with this nutritional transition comes urbanization, and with it, an increased opportunity cost in people's time with these urban jobs, and particularly women's time. There hasn't been, I think, a lot of research on this, but a few neat papers show that this increased opportunity cost of women's time and demand for women's labor leads to an increased reliance on fast food and street food, both in Asian countries and in sub-Saharan African countries. And again, this doesn't have necessarily clear impacts, I think, for micronutrient consumption, but many of these foods rely on refined wheat or rice, fats, oils, salt, sugar, and so possibly in some cases and for some populations, this might lower the density of micronutrients in diets. Some things consumers can control about their foods and choose, and some things they really can't. There's a great paper by Cornell's Miguel Gomez and Katie Ricketts on the lengthening and formalization of food value chains as countries develop. And this type of longer, more formal food value chains getting to urban populations in poor countries has definite implications for the perishability of food. Foods lose micronutrients or lose vitamins specifically over time, particularly at ambient temperatures. If you see this graph on the right, it's showing the degradation of vitamin C over time, and for spinach specifically. And for the spinach that's kept at fairly cold temperatures, the majority of vitamin C is lost within a week. For the spinach being kept at warmer temperatures, which clearly is very common in a developing tropical country where food is being shipped into urban areas by a large truck. most of the vitamin C is lost within 2 or 3 days. Vitamin C is particularly unstable, but B vitamins are also prone to degradation and some others. So also with a rise in income often comes increased processing of grain, as Chris mentioned. And very often, and at a higher, more and more as the processing gets more and more fine, this processing will remove bran and germ. And with that, much of the iron, the zinc, the calcium, the vitamins, phytate protein that come in these grains. This sort of processing can happen at a very large, This sort of processing can happen at a very large level on a country scale where plants are doing this processing and shipping out their products all across the country. It could also happen at a village level. A couple summers ago, I was working in Humbo, Ethiopia, and the very first thing that these communities did when they got carbon credit money from the World Bank was to buy grain mills, the very first thing, every single one. This table below shows that for maize, rice, sorghum, and wheat, up to 70-80% of iron and zinc can be lost through heavy processing. Of course, with this sort of institutional food processing also comes the possibility for food fortification. This can be done for milk, sugars, oils. It's very common in the US particularly. And this can definitely increase levels of increase intake of certain types of micronutrients. But success depends on having large processing plants who are able to successfully do this, as well as having government oversight and having consumers who are willing to pay for these modified and hopefully more valuable goods. I hardly need tell this audience that the production of micronutrients has very strong implications for the consumption of micronutrients. This is particularly true in subsistence and semi-subsistence areas, but it's true in a lot of populations across the world. An example, there's a couple great papers by Chilemba et al., 2011 and 2012, showing that soils in Malawi are selenium deficient, and this causes the maize grown in Malawi to be very low in selenium, and the Malawian population, at least some areas, has very low intake of selenium. They also show that by applying selenium-enriched fertilizers to the soils, you could increase basically the entire population of Malawi to having a safe intake of selenium. A lot of people have mentioned the Green Revolution technologies so far. Clearly, they increased calorie consumption, and they may also have, by increasing cereal monocropping, inadvertently decreased the production of iron and zinc-rich legumes. South Asia is a great example of this. In the 30 years after the Green Revolution, the production of rice and wheat increased by 200 and 400%. There was a sharp decline in the production of legumes, a decline in the iron density of the average diet in South Asia, and a marked increase in the percentage of anemic women in the region. The Green Revolution also emphasized the use of fertilizers, which clearly give a bump to physical productivity of crops. However, excessive application of NPK fertilizer can, in at least many contexts, decrease vitamin C in horticulture as well as some other vegetables. It decreases the uptake of zinc and iron in grains in many contexts. This depends a lot on the specific soils, the specific crops that are being looked at, but there are definite trends in the soil science and crop science literature. And biofortification is a sort of producer-level version of fortification. Instead of targeting consumers and asking them to pay more to purchase enriched food, you're targeting producers and asking them to produce more micronutrient-rich food. I think this is a really exciting possibility for increasing micronutrient intake in much of the developing world. Harvest Plus is doing really great research and work along these lines, but I think it's a little bit too early to tell in many contexts how it's going to work out. Success depends on adoption rates, disadoption rates, marketability, whether people just produce it at home and eat it at home or whether they end up selling it to their neighbors in the village, the longevity of the micronutrient density of those crops, and whether 5 or 6 years down the line they've mixed up the micronutrient-rich potatoes with the non-micronutrient-enriched potatoes or beans or grain. So looking forward, I think it's really clear that this stubborn persistence of micronutrient deficiencies, especially in the face of rising income, points to there not being one or two or three areas where these problems are originating, but that these problems are originating at multiple levels in the food systems, and thus require really looking through the entire food system for solutions. In some places, it may be that production level interventions are the most efficient and work the best. So for instance, in Finland, a mandate that fertilizers all be enriched with selenium took the entire Finnish population from a dangerous, according to the WHO, level of selenium intake to a safe level of selenium intake. As Chris pointed out, the success story of iodized salt increasing levels of iodine intake pretty much globally by now really points to the fact that in some places, or perhaps for some micronutrients, tweaking the food value chains may be the most efficient way to go about changing micronutrient intake. And in some places, consumer level interventions on a person-by-person basis may be the best. I think that the success of education programs for child feeding and the health impacts, the long-term health impacts for children whose mothers went through child feeding programs really points to potential success in this area. So forward-looking policy research must first identify where micronutrient deficiencies are severe and widespread, clearly. That sounds sort of obvious, but the fact is that we really don't know. We don't know who is selenium deficient. We don't know who's zinc deficient. We need to determine the root sources of these deficiencies for distinctive groups within geographic regions, and it's definitely going to be different for urban, for rural, even maybe for pregnant women and non-pregnant women, children and adults. We need to evaluate the cost effectiveness of options comparatively across the food system and not leaving any interventions off the table. I think that it's really easy to get stuck thinking that there's only a few things that have been shown successful in the past, and we need to reopen some of the possibilities that maybe were looked at more a few decades ago but haven't really been written about for a while now. And we need to develop useful rules of thumb, after all that, for targeting interventions to these particular groups. So that's it. I want to thank you guys, thank Pear. And on a personal note, I'd like to say that Pear's work at Cornell has absolutely influenced my research interests as a grad student here. I'm a fourth-year PhD student in applied economics. His lectures, his papers, his classes, and I think perhaps above all, his founding of the IGERT Food Systems and Development Program here, along with other professors, has permanently shaped my research interests, and I think for the rest of my career, my research agenda. I think that's probably true of many, many Cornell graduate students over many years. And probably all of our disciplines are a lot better off for it. Thanks.
Thanks.